Good evening, and you're welcome to Study Statistics with me, Osman Abdul Baki. Today, our topic is set theory. Under a set theory, we are going to have a proof. We are going to have the proof of this. So, before then, I am a final year student at Kwame Nkrumah University of Science and Technology, reading BSc Statistics. Today is the 2nd of February 2023. All right, without wasting much time, let's go straight to the question. So, this question is a proof under set theory. So, that is logic and set. That is the portion of set theory. So this the question is that prove that A is a subset or equal to B if and only if A intersection B is equal to A. So we are proving that A is a subset or equal to B if and only if A intersection B is equal to A. But remember, this is the assumption. So this is the assumption. This is the assumption. So we'll be proving this based on this assumption given. So this is the question, and this is what we are driving on. That is A intersection B. Sorry, A is a subset or equal to B, given that A intersection B is equal to A. All right. So when we take A intersection B, when we say A intersection B, it means that we want to find a certain element in which can be found in set A and set B. So there is an element of X that is an intersection of A intersection B. Sorry, there is an element of X which is a member of A intersection B. A intersection B, which means there is an element of X in which that X can be found in A and as well as at the same time can be found in B. That element is called the X. So being it set A and set B, this element can be found in set A and at the same time in set B. So mathematically we write it in the form of this, and we can also write it in the form of like this, in the form of this, where X is an element of A and the intersection represents the end. So X is an element of A and an element of B. So the intersection is the same as the end. Don't forget about that. All right. So continuing with the solution. If X is an element of A intersection B, meaning X is an element of A and an element of B. If X is an element of A, then A intersection B is a subset or equal to A. Don't forget the pattern. If X is an element of A intersection B, and here X is an element of A, then if X is an element of A, the same thing that A intersection B is a subset or equal to A. So we can find this X both in A and B. If we can find X both in A and B, and if we can find X in A, the same thing as A intersection B is equal to or is a subset of A. Hope you get me right. Which means there is an X in which can be found in A. If it can be found in A, which means the its intersection is equal to that set A, or the intersection, or maybe the intersection of A intersection B is a subset of that set A in which that same X can be found in A. So this is what all is about. So now moving on with the question or with the solution. Taking X as an element of A as we just explained here, and since A is a subset of B, subset or equal to B, and X is an element of A, then X is an element of B. This is so simple. X is an element of A. X is an element of A. If X is an element of A, then X is an element of B. Because here A intersection A is a subset or equal to B. Hope you understand. So hence X is an element of A intersection B. Thus A is a subset or equal to A intersection B, which means A is a subset. The elements in which contained in X can be found in the intersection of A and B, or that element which is in X is the same as those elements in which we can find in A intersection B. Remember, A intersection B is the elements in which are common in both sets, both in set A and set B. So hence A intersection B is equal to A. Yes, because there can be an element in which can be found in A intersection B, as well as that element is also the same element in set A. Hence, A intersection B is equal to A. Remember, this is not our final solution that we are looking for. Let's go back to the question. The question said, prove that A is a subset or equal to B. So this is the assumption given, where A intersection B is equal to A. So this is our assumption that we have come to. Now let's move on. Suppose A intersection B. Suppose A intersection B is equal to A. So this is the assumption. So this is the assumption that we have derived on. A intersection B is equal to A. Now taking any element of A, which is X. X is an element which is found in set A. Any element at all. So, but here we are representing any element in A as X. So now, X is an element of A. So if X is an element of A, which means A intersection B is equal to the set A, or the element in set A. Remember, A intersection B means element in which can be found in the intersection, both set A and set B, which is equal to the element in which set A has. So if A intersection B is equal to set A, then we can say that X is an element of A intersection B. I hope you get me right. Which means X is an element of A intersection B. Which means A intersection B has a common element, which is X. Because this X can be found in set A. You know, A is a set too. So let me just give you an example. A is a set like maybe any element 1, 2, 3. Let's say 1, 2, 3, and we will say that B is also a set. B is also in a set like, let's say 1, 4, 5, which means there is an element X which is 1. You know, 1 is in common. One can be found in A and 1 can be found in B. So let's say that element 1 is A. So let's say that 1 is X. So this is an intersection which can be found in both A and B. So therefore X is an element in A and X an element in B. Therefore A is a subset, which means this A is a subset, which means this A can be found in B. It's a subset of B or equal to B. So A is a subset. So A is a subset of B. When we say subset, the elements of A can all be found in B or equal to B, which means all the elements in which A has can be equal to B. So that's the final conclusion. Hence, A is a subset or equal to B. I hope you get me right. So this is the end of the solution. Thank you very much. So this is all that we are doing for today. And in our previous meeting or in the subsequent meeting, we'll be having a probe or more questions that deals with technical matters. In fact, this is some sort of technical. You have to sit down and think critically before you get the solutions. So these are all what we have for today, and I'm sure you heard me right and you understood what we did for today. Thank you very much. Once again, my name is Osman. You can contact me on my mail, osmanabdulbaki427@gmail.com. osmanabdulbaki427@gmail.com. Thank you very much for having time with me. Goodbye.